So in the previous lectures, we have studied the what is the basic of CNC, difference between the CNC machine, NC machine, and DNC machine. Okay, how it is beneficial for the automation part. So we have studied in this. Also, we have studied the basic part of part programming. That what are the basic structure of the writing the part programming. What are the different syntaxes. Okay. So now we will go some examples and some this uh, graphical illustration of the part program in this lecture. So application of some codes like G01 linear interpolation as an example for the motion that occurs in XY plane with the same maximum speed for the X and Y axis. Initial motion is at angle of 45 degree to the axis until motion is one of the axis is completed, and then the balance of the motion occurs in the other axis. This is called point to point motion. So application of some codes like G01 you can see. So positioning from motion A to C, N10 is the block number, then G0 is the preparatory function, X is the X coordinate, okay, then Y coordinate, then feed. So this is the command you can see from A to C. How will you go? So from point to point function, how can you use linear interpolation code G01? Okay, so you can see here. So N10 X1 Z1. So Z is the means maximum depth of the we require. So we can go step by step. So from Z from 0.1, then 0.1 to 5, this 0.1 to 5. We can go for a speed feed rate means point by point. We cannot go for directly whole Z because the tool can be broken. So that's why we write the step by step of the Z. So you can see N10 X1 Z1. Then N15 0.1 means before touching the tool at some distance Z is kept. Now after the speed is given and the Z is given minus direction, feed is a 5. So N20 G01 linear movement G01 Z minus 0.1 to 5 F5, then N25 X2 Z2 F10. Then comes G02 circular interpolation. So if we will write now G02 code in the same command, then what will happen? G01 will be deactivated. So this is called the set and the self-holding function. So G02 is also a preparatory function to specify that the tool should be moved to a specified location along a circular path in a clockwise direction. In order to specify the paths to the MCU, machine control unit, the end point of the arc and the location of the center of the arc should be specified. So this is the block in which the G02 coding program, the center of the arc is given by specifying a location and the start of the arc. Okay. So G02 is the circular interpolation, circular movement in a clockwise direction. Okay. So this you can see the example in the graphical representation. So G02 command require the end point and radius in the order to cut the arc. So I, J and K are the relative start point. So N block number G02 circular interpolation command to battery function G02. X2 is the X coordinate from here to a start. Y1 is then I0 J minus 1 F10 like this. So we have to give in the circular interpolation start in an end point, start of the end point, the radius for producing the arc. So you can see circular interpolation from A to B about a circle centered at C. N10 G02 X coordinate, then Y coordinate, then I, then J, then F. So this is a basic syntax of G02 command of basic circular movement in the clockwise direction for that. So what is CAD cycle? So the sequence of some machining operations is may be the same for any part and for any machine. For example, drilling a hole involves the following steps. Position on the tool, you have the point where the hole to be drilled. Set the correct splinter speed. Feed the tool into the workpiece at a controlled feed rate to a predetermined path. Retract the tool at a rapid rate to just have the contact point from where the hole started. So this is CAD cycle. CAD cycle means for an operation, the cycle of different operations are there, different steps are there. Suppose for drilling, First you will position the tool, we have the point where we have to drill the hole. Then we have to correct the spindle speed, at which spindle speed that this spindle will rotate, and feed the tool into workpiece at a controlled feed rate to a depth, then retract the tool at a rapid rate. So these are following samples cycles. So example which can cycles are G81 for drilling, like down feed, continuous feed, at bottom no action, traction rapid. So G82 a spot face counter boring for counter boring holes. For a spot facing we are using G82 codes. So here continuous feed is there. So at bottom some stop is there. Then rapid retraction is there. G83 for deep hole drilling. Also down feed is pure drilling. No action is required at bottom, and rapid retraction is there. G84 is tapping, so continuous feed is there because the spindle is there. Then feed rate is retraction. Okay. G85 through boring in and out, continuous feed, no action, feed rate. Okay. So in through boring, continuous feed is there, but at bottom there is no action is taking place, but feed rate should be retraction. G85 through boring in and out, then G86 through boring in only. Continuous feed is there, stop a spindle, then feed rate retraction. So in there are some example of CAD cycles, especially these all CAD cycles are mainly involved in the drilling or the drilling operation like spot facing, counter boring, deep hole drilling, tapping, through boring. So G81, how G81 can be used for this illustration purpose, you can see. So G81 was for drilling purpose. So in this is the hole to be drilled for this. Then we will first position the tool of the drilling point. So N5G00 rapid movement in air. So we are moving the tool in the air, and it is kept you have the just drill point. So NG5G0X0Y0Z1 means we are making that a location where we have to drill at the 0 point, and we are keeping the tool in the starting at some place you have the drilling point. So Z1 is the 1 millimeter you have the drilling point. So N10 X1 Y1 Z0.5. Then we are in the step we are reducing the Z value, means we are bringing the tool close to the drilling point. So now Z is 0.5, means just 0.5 millimeter you have the point. Now next block G81 means we are starting the drilling. Z minus 0.25. So Z will go means depth of the drill hole will go 0.25 millimeter. Then radius of the drill will be 0.125, and then F5 means feed rate is 5 millimeter per minute, or whatever setting you have done in the pinch or 2 millimeter like this. So this is the basic G81 illustration. So you will see in the first step what you have been the tool you have the just 0.5 millimeter you have the drill point, but in second step the tool rapids from the Z plane to the rotate plane 0.125. So that now the Z is going in the other direction, means the drill point has started its work. At the drill point drilling has been started. So starting at the Z retract plane, the tool feeds down the Z depth 0.25 at the specified feed rate. So in the third block you can see G81 G minus 0.25. So in the B parts these things happening are 0.125 radius is there, then up to the 0.25 millimeter depth, feed is at 5 millimeter per minute. Then C part, then the tool will come back, you have the 0.5, so the detection distance is 0.5. So in the same way we can cycle is repeated in this. So the drilling includes this cycle. First you keep the point, then you drill, again you retract. So they are CAD cycle examples. So the tool then comes back to the original point, is Z is equal to 0.5. So the tool will come after the drilling, retract its path, and will come to the Z edge, means 0.5 millimeter of the this drilling point. So this is located in the third point. So these things are included in the CAD cycle. So in the same way for counter boring, spot facing, okay. So in the same way counter boring, then through hole, tapping, all things cycles are coming here. Only the code is varying. But the cycles are same, but only codes are same. The G81, 82, 83, 84, whatever they said in the last slide. So these things come. So this is an example of CAD cycle illustration. How the G81 code means for drilling we can use. Similarly, we can go for typing. Similarly, we can go for counter boring. Only G82, 83 like this. And what at what distance you will say. So these things, all the CAD cycle will include in different cycles, especially mainly to drilling. So first you will make the this tool close to the drilling point, then you start the drilling. Okay, then after that the tool will move back to its origin point. So these are the CAD cycles. So for this, there are some common examples I have discussed. You can go for different examples and different solutions and different problems in different handbooks and books for better understanding of G codes and M codes and better understanding of the part programs like this. And you can read books like P and Rao also in Google or internet material, NPTEL lectures, NPTEL materials, MIT lectures and materials also. So you can go through the mentioned books like reference books, computer numerical control for this book you can refer. So these things we have discussed today. How we can today we have discussed how we can use a G code and G01, G02 functions. What are the requirements for that commands to be written? Then how we can go for and how we can go for the needs kind cycle program and kind cycle functions. How we can use what are the cycles involved. How we can define the functions in CAD cycle. Thank you. Thank you for patient listening. Thanks.